Hello. Today we'll be looking at the 2013 Middle School Math Olympiad questions from Washington State. So let's get started. Miss Smith keeps 2 reward envelopes in her desk. They have colored red, blue, and orange squares in them, and each color corresponds to a prize. Envelope A has 3 red, 4 blue, and 1 orange square. Envelope B has 2 red, 2 blue, and 2 orange squares. The only way to get the prize is to give the correct probability for the color you draw. Miss Smith pulls out a reward envelope at random, and Eric selects a square from that envelope at random. What probability should he tell her if he draws a red? Express your answer as a fraction in lowest terms. Here we have 2 reward envelopes, envelope A and envelope B. Let's start with envelope A. Envelope A has 3 red squares, 4 blue squares, and 2 orange squares. Next, envelope B has 2 red squares, 2 blue squares, as well as 2 orange squares. Now that we've visualized and understood the problem, let's take an example before we jump into solving this question. In this case, let's look at marbles. Out of these 8 marbles, there are 3 light blue marbles, 3 dark blue marbles, and 2 white marbles. If I close my eyes and randomly pick a color, let's say I pick a white marble, the probability of picking a white marble out of this group of marbles is 2 out of 8, as there are 2 white marbles and a total of 8. Again, let's say I close my eyes and pick up a dark blue marble. The probability of picking this dark blue marble is 3 out of 8, as there are 3 of these marbles and there are a total of 8 of them. Now that we've understood how to find probability, let's jump back into solving this question. As this question is asking for the probability of Eric selecting a red card from an envelope at random, we must start by finding the probability of selecting one or the other envelopes. As Miss Smith has 2 envelopes to select from, and there are only one of the envelopes that can be selected, the probability to select either one of these envelopes, envelope A or envelope B, is 1/2. Now let's start with envelope A. As envelope A has 3 red squares out of a total of 8 squares, the probability of picking a red square from envelope A would be 3 out of 8. Similarly, let's find the probability of picking a red square from envelope B. As envelope B has 2 red squares out of a total of 6 squares, the probability of picking a red square from envelope B is 2 out of 6. Now that we found the probability of picking either one of the envelopes, the probability of picking a red square from envelope A, as well as the probability of picking a red square from envelope B, we must multiply each of these values. For one, we must find both the probability of picking a red square and ensuring that that red square is being picked from envelope A. To do so, we multiply. Therefore, we would multiply 1/2, which is a probability of picking envelope A, by 3/8, which is a probability of picking a red square, to get 3 out of 16. 3 out of 16 represents a probability of picking a red square that is from envelope A. Similarly, we can do the same for envelope B. As the probability of picking a red square from envelope B is 2 out of 6, we can multiply both of these values to get 1 out of 6, which would be the probability of picking a red square from envelope B. Now that we have both of these values, we have to add them to find the total probability. As in this case, Miss Smith can pick either envelope A or envelope B, and Eric can pick a red square from either envelope A or envelope B. In this case, we would use the operation of addition, as you can pick either envelope A or envelope B. Therefore, we would add 3 over 16 plus 1/6. Therefore, we can use the least common multiple with a denominator of 48 and simplify down to 17 over 48. Therefore, the probability of Eric picking a red square is 17 out of 48.